Do you know that urban flooding and extreme weather could paralyze modern cities? But AI hypercars are changing the game. In rain-soaked cyberpunk streets, these vehicles operate with precision far beyond human capability. LiDAR, radar, and predictive neural networks combine to create a constantly updated virtual map. Vehicles communicate in real time, forming a living swarm that adapts to floods, storms, and urban chaos. Imagine a city where storms no longer halt movement. Neon reflections shimmer on puddles as AI hypercars glide past, calculating every hazard. Cockpit HUDs display predictive overlays, flood sensors, tire grip, and pedestrian paths. In extreme weather, milliseconds matter. AI continuously adjusts acceleration, braking, and steering to prevent skidding or collisions. Dynamic lane formation prevents collisions. AI cars move in synchronized swarms, projecting holographic safety zones. Emergency vehicles are given priority. AI forms protective corridors automatically. Drones hover overhead, relaying real-time data to vehicles. The cars and drones operate as a coordinated ecosystem, transforming urban mobility into a proactive intelligence system. Simulation labs train these vehicles on thousands of scenarios. Flash floods, heavy storms, traffic congestion, sudden obstacles. AI learns from every scenario, anticipating and responding faster than human reaction times. Even under chaotic urban conditions, AI hypercars optimize energy use. Regenerative braking captures energy. Predictive routing reduces unnecessary acceleration. The cockpit becomes cinematic. Neon reflections ripple across rain-streaked glass. Dashboards project predictive graphics. Semi-autonomous controls assist subtle driver inputs. On a citywide scale, AI hypercars operate collectively. Aerial views show neon-lit highways filled with glowing vehicles in synchronized patterns. Holographic flood maps overlay streets, showing traffic flow and hazards in real time. Emergency scenarios highlight AI potential. Stranded pedestrians are detected, vehicles form protective corridors, drones provide aerial assessment, and traffic reroutes dynamically. Storms intensify, wind gusts, rising floodwaters, but predictive algorithms continuously calculate optimal speed, tire grip, and suspension. Each decision is precise and instantaneous. AI anticipates both vehicle behavior and environmental changes, including pedestrian movement and flood patterns. Cities with AI hypercars become resilient ecosystems, with traffic flowing safely even during disasters. The question remains, would you trust an AI car to navigate a flooded, storm-ridden city? Could you rely on predictive intelligence to safeguard your life, passengers, and time?